This is the part 2 video of recursion where we will be learning what is recursion and how it works with a clear example. As you can see, the function that calls itself again and again, there is one example and the arrow going forward direction, and this function is calling itself. When it reaches the base case, the call terminates and the caller goes back from the final call to the initial call. So this phase where the function is calling itself again and again with a reduced value of n is calling phase or ascending phase. Okay, when it reaches the base case, the handler returns back to the previous call. So this will go up until it reaches the initial call where it was called for the first time. So this is known as the returning phase or the descending phase. Okay, this is known as the returning phase or descending phase of recursion. Recursion has two phases. One is calling phase and the another phase which is returning phase. The function calling itself again and again until it reaches some base case is known as recursion. It has two phases, recurring and one calling. Okay, the first one is calling phase. Okay, as you can see, this is calling or ascending phase, and the returning part, which is the second phase, which is returning or descending phase. Okay, the recursion is working like this inside the memory. So let's see this, how memory is divided. Memory is divided into three parts. First is heap, second is stack, and the third is code section. I am showing this the memory. Inside the memory, what it does is divides three memory parts, which is code section, heap, and stack. So let me show you one recursion example with a function which is recursive function. Okay, I am writing a C++ code to make you understand and get clearer view of how recursion works. So this function returns nothing, so we have taken a return type of void. We have created one function fun, which is taking parameter as n. Okay, the base case that I have defined is when n value is greater than 0, we need to perform some steps. So the basic steps we need to perform. First step is printing, second step is calling itself. First is printing, second is calling itself for reduced value of n, which is n minus 1. Okay, how it will work, I will show you. Let me show you the main function code. Okay, I have passed in the main function the value of n I have passed is 3. So it will invoke the function. Okay, it will call the function fun with a value of 3. Let's see this with a tracing tree. Let me give you one clear view. What are the steps that we are going to perform in order to trace this function? So let me search where I have written on this steps clearly, so that you can understand how this function is going to work and what are the works that it is going to perform in order to trace our tracing tree. Okay, let me show you some written steps. These are the written steps. Let me show you. Okay, yes, the steps that we are going to perform in this recursion is, first it will print. First step is printing. Second is calling itself for reduced value of n, which is n minus 1. These are the two steps that we are going to perform in order to trace our recursion. These are the two steps. How it will work inside the memory, I will show you. First, let me show you the tracing tree. So first, the value of n we passed is 3. As you can see from the code also, we have seen that we have passed the n value as 3. So the first value passed to this function is 3. So let me create an activation record inside the stack. Anything you define is created inside the stack. Any memory that is getting, any variable that is getting memory will be placed inside the stack. So there will be a function call and memory of that function will be created here. Allocation will be done here. So the first f of 3 is created inside the activation record of main function. So first step is printing, so it will print 3. Let me now write the output. So it will print 3 first. Again it will make a fresh call for n value of n minus 1. So it will call itself for f of 2, which is 3 minus 1, which is 2. So let me update the stack. So again a fresh call is made. Okay, fresh call is made for f of 2. The first step was not finished. The second step has called again itself with a reduced value of n. So the first step was finished printing, but the second step is recursive call, so it will go and finish it, then again it will print. So now you can see the base case was what we have defined is n greater than 0. So first initially value of n was we defined or we gave it was 3. So now it is reduced to 2. Okay, now it is reduced to 2. So 2, first it was 3 greater than 0, so it printed 3. Okay, it printed 3 as we have already seen from our tracing tree. Now the value of n is reduced to 2, which is 2 greater than 0. This is also a true condition, so it will print 2 and again it will make a call itself for reduced value of n. So it will print 2. Let me write in the output. It will print 2. Okay, it will print 2. Again it will make a fresh call from f of 2 to f of 1, which is n minus 1. Again let me update the stack. Now the function is getting value of n as 1. Okay, let me update the stack. Yes, now we have updated the function call. Now the fresh value of n, let me update the n value inside the memory. So the n value is 1. So 1 is also greater than 0. So n value should be greater than 0. Yes, n value is greater than 0. So again it will print. So what is the value of n now? N value is 1. So it will print 1. Okay, it will print 1. It will print 1. Okay, it will print 1. Again it will make a fresh call for n minus 1, which is 0. Again it will make a fresh call inside the stack. Let me update the stack. It will make a fresh call for f of 0. Now the n value is reduced from 3 to 1, and again now its value is 0. N is 0 now. Let me update the n value inside the memory. Now it is 0. Got it? Now the n value is 0. Here is a conflict. 0 is not greater than 0. The condition fails. We have reached the base case. There is no more call from this function. So the call terminates here. Let me remove this from the stack. So it will be removed from the stack. The call is terminated. There is no calling again. It goes back to the previous call, which is f of 1. Let me show you in the tracing tree. F of 0 is reached. The base case is reached. So it goes back to the previous call from the final call. So f of 1. First step was finished. Second step is also finished. So this function has also done all the work. So it is also removed from the stack. Again the handler goes to the previous call, which is f of 2. Let me show you in the tracing tree. F of 2, both the steps were completed. As you can see, both the steps are completed. It has done printing and calling itself. So this is also done. So this will be also removed from the stack. F of 2 is also removed from the stack. A handler goes to the previous call, which is f of 3. Let us go to the tracing tree. Both the steps were completed, as you can see, printing and calling itself. So this is also removed from the call stack, and the handler goes to the main function where it was initially called. The function was initially called from the main function, so it goes back to the main function. It has printed the output, which is 3, 2, 1. I hope that explanation was clear how the recursion works using the tracing tree as well as the call stacks. So now let me show you the analysis of how the calls were made inside the memory. For n value of 3, it made 4 calls. As you can see, there are 1, 2, 3 and 4 calls. There were 4 calls for n value of 3. So if you provide n value of 4, it will make 5 calls. If you give n value of n, then it will go until n minus 1 calls. So this is not 0, this is 1. So a polynomial degree of n here is 1. Highest degree is 1. So let me update it. Highest degree is 1. So we have taken the highest degree of polynomial of 1. So we have taken order of n. Big O of n. Time complexity is big O of n. This recursion takes time complexity of order of n. Okay, let me show you most of the important point that I have written here. Okay, let me show you. This type of recursion, as you can see, this type of recursion is tail recursion. What we have just now seen is an example of tail recursion. Everything is done at calling time. I have done everything at calling time. Nothing is done nothing is done at returning time. We have done no work at returning time. This has only ascending phase, no descending phase. Okay, it has time complexity of order of n. So this code has a time complexity of order of n. See you in the next video.